Hello everyone, I am Detectors. Welcome you all on our channel eFunda. New day, new topic. And our today's topic is responsibilities of an instrumentation 3D modeler part 15A. And if you are new to our channel, then please visit to our channel eFunda and watch all the videos related to the topic of engineering, project and career, as well as the fundamentals and specially made in instrumentation and control engineering related topic videos. Similarly, we have also created part 15 series, that is introduction to 3D model and software. That was the last video. And don't forget to subscribe to our channel to get latest notification on upload of our video on our channel eFunda. So let's begin with our today's topic, that is the responsibility of an instrumentation 3D modeler part 15A. As part of instrumentation deliverable generated from 3D modeling series, we have already created introduction of a 3D model and software part 15, and now we are doing today's video, that is the responsibilities of an instrumentation 3D modeler part 15A, that is this video. And future video will be instrumentation deliverable generated from 3D modeling part 15B. Under the topic of responsibilities of an instrumentation 3D modeler, we are covering today the purpose and responsibilities of an 3D modeler. Purpose: 3D model lets team construct any shape imaginable while retaining production capability and help vision come together with relative ease. Modern 3D modeling provides a level of design depth that rough sketches or a 2D design cannot give, such as a improved control over detail. Under documentation, 3D modeling is engineering enhances your data management to organize and manage your design asset and document. It allows you to standardize on the detailing and the drafting procedure, automating your processes and increasing speed as well as accuracy of output. Design efficiency: simply put, 3D modeling help to reduce the time and money needed for design. 3D CAD software let each component of a structure or a product be checked, tested and revised before going into production. This helps to avoid costly returns to the drawing board. Modeling of a local panel, instrument cabinets, pipe sleeves and instrument ducts are also come under the responsibility of an instrumentation 3D modeler. Now further in this video we will see various types of modeling activities are being carried by 3D modeler. Modeling of process instrument. This shall cover installation aspect one can see in a pictures, including stanchion mounted, tapping point, elevation view and represent in the form of 2D image. One can see in a photograph installation of a pressure transmitter for liquid service and the tapping point given by the piping, and there near to that we must install the pressure transmitter for the liquid service that was designed and made in the model. One can refer in the images. Similarly, on the right hand figures one can see in the photographs how the transmitter object is being modeled and how the stanchion support and transmitter is being shown in the digital medium, that is a 3D modeling. Further in second modeling of a process instrument page, where one can see the pressure transmitter installation for the gas service and pressure transmitter location and pressure gauge as well as the tapping point from the piping. One can see how the transmitter is installed with the help of support, complete stanchion, tray, connectivity for laying the cable and the tapping point below. Similarly, so as to have a local indication we are using pressure gauge. On another photograph, one can see how the pressure transmitters are installed with the help of this complete design. This is a typical photograph of installation of a pressure instrument, that is the pressure transmitter and the pressure gauges. Modeling of level instrument, one can see in a photograph. On the left hand photograph, one can see GWR, that is a guided wave radar type level instrument installation. One can see the vessel and the tapping provided by piping, and the GWR is installed. Mounting chamber also can be seen, and this installation is carried out such a way that it will be accessible from maintenance and operation point of view. Similarly, the drain connections are also shown, and isolation walls are provided between the piping valve as well and vessel. Similarly, on the other side of the right hand side photograph, where one can see how the modeling activities are being done. This is a pictorial representation of a field installation. This will give idea how the installation will be carried out and what are the constraints it will be coming during the installation. This is a very good example of visualizing actual installation at the site and avoid the future rework during the construction activities. Modeling of junction boxes. This shall cover installation aspect including stand and provision to lay cable tray. One can refer below photographs from the model as well as from the typical installation. Cable tray laying and maintain required access without any clashes. One can refer the snaps from the 3D model where JB frame is done, where 2x2 combination junction box frame is used, and similarly one can refer the space between two junction boxes where we will lay the cable tray so as to have the cable connectivity from the field instruments to the junction boxes. This is how modeler ensure that typical JB installation is done, and one will check whether it have a relevant maintenance operation access for future purposes. Modeling of instrument cable trays. This shall ensure that all the required cable tray network is modeled considering the cable connectivity to all instrument and cover installation aspect including tray, clearances and clash free model. These all you can see from the snaps from the 3D model, where in the left photograph one can see the electrical and instrumentation cable trays are shown. One can see how the network is laid between entire deck area, where intermediate cable trays are also laid so as to have a complete connectivity of a trays where you will lay the cable. It will go to each equipment, and from instruments to junction boxes and from junction boxes to marshalling. This is how the network is being placed. Similarly, while entering or going to the control room, one can see the pipe rack or a rack where cable tray installation is done. Cable ladder tray is installed and intermediate cable ladder supports are provided so as to hold the cable tray, and this will not obstruct or have a lateral movement while cable laying on this cable tray. This is how modeler ensures that all the required sizes of a cable trays are placed within the plant area with adequate and correct connectivity to the respective branch instrument as well as equipment which will have main connectivity to the main cable tray. This is how the instrument cable trays are modeled in the 3D model, which will give the complete visualization, and this will help you to avoid any rework during the construction work. Modeling of fire and gas detector. This shall ensure that all the required FNG detectors are placed based on the FNG mapping study and adequate coverage as per safety requirement. One can refer below snaps where, for example, flame detector is installed so as to cover the area where flammable atmosphere is present. One can see the stanchion is also installed so as to provide the supports to the flame detector along with canopy. Cable tray supports are also connected to cable tray so that it will be easily cable laying can be done from the junction boxes to the flame detector. Thanks to instrumentation.tools.com for this picture. Similarly, one can see the another photograph actual installation of the detector. This is how modeler always ensure that it will have a adequate coverage as well as the complete supporting of the flame detector and cone of vision. That means no obstructions will be there between the detector sensor and the actual source of area. With this, we are concluding on our today's topic, and you can find our channel details as follows. If you are new to our channel, that is our YouTube channel eFunda, then subscribe to our channel eFunda and don't forget to press bell icon to get latest notification of upload of our new video on our channel eFunda. Similarly, you can follow us on a Instagram page. Similarly, you can follow us on our Facebook page as well. And keep watching our channel eFunda for various topics related to engineering and a project. With this, we can assure you this will help you to better your understanding on engineering and a project topic. Keep watching our channel eFunda. Thanks. Watch our channel for new day, new topic.